not an algebraic solution. All right. So if you need to make a note of that, please do so. Guess and check is not algebra. All right. It's been on my list of things to reinforce because on the last test, I saw a fair amount of that when the question asked for an algebraic solution. Folks were doing guess and check, and that's a big no-no. All right. So algebra is involving, well, for our purposes, so far anyway, because we've only learned a limited amount of algebra, properties. All right, properties of equality, properties of inequality, the ordinary properties like commutative property, associative property, and things like that. All right, distributive property. All right. So in this case, what we're going to do is we're going to look for a way to eliminate a variable in one equation using the other equation. All right. So the first thing I notice is in the first equation, I see that x is equal to y minus 1. All right. What this means is that x can be replaced with y minus 1 in the second equation. All right? Because it's establishing equivalence. It's telling us that x and y minus 1 are the same thing. All right? So in my second equation, I can replace that x with a y minus 1 because they're the same. So I'll make that substitution. All right? So y minus 1 plus 2y is equal to 8. All right? Just by replacing the x with a y minus 1, I went from having two equations with two independent variables, two variables that are independent of one another, is what I really should say, to having a single equation with only one variable. All right? We have the understood coefficient of 1 in front of the y. All right? This coefficient here can be combined with this coefficient here through addition. 1y plus 2y is equal to 3y. So 3y minus 1 is equal to 8. Poor quality equal sign. Poor quality 8. Hold on. There we go. All right. And now I'm just solving a linear equation. I just want to isolate the y. I'll add a 1 to both sides. I'm going to get 3y is equal to 9. I'm going to divide both sides by 3. And I get y is equal to 3. All right. When we put this into the calculator, we knew that the y value is going to be equal to 3. All right. X comma y, 2 comma 3. All right. So algebraically, I just need to find what the x value would be corresponding to that given y value. So what we do is we choose one of the two equations, choose one of the original equations, all right, whichever one you think is going to be easier to work with. All right, ultimately I'm looking for the value of x. I think it's probably a good idea to choose the one that has x all alone. X is equal to y minus 1. If I could choose either of them, choose the one where it's x equals. All right? Substitute in the given value of y, or substitute in the value of y that we just discovered. Well, I'll just say 3 for y. Try to make it a little bit more concise than what I was about to write. Substitute 3 for y because we know that y is now equal to 3. All right? We determine that right here. Y is equal to 3. Make that substitution. So x is equal to 3 minus 1, which means x is equal to 2. So my answer, or my solution, always x comma y. All right, so 2 comma 3. The x value comes first. All right. So a little substitution goes a long way. All right. Now, in number 4, so I'll just do one more and then I'll give you the time to practice this. Because there's really two types of problems when it comes to substitution. One where it's given in what we call an explicit form, where it's not solved, where you have at least one equation that's not solved for a variable. Like in number 3, we had x plus 2y equals 8. It wasn't solved for x, it wasn't solved for y. All right? But then we have ones that are in explicit form, so those were in implicit form. I mean, the vocabulary is not that big of a deal right now. They're in explicit form in number 4, which allows you to do it in a little bit more concise of a manner. All right? Because if I tell you that x plus 2 is equal to y, and y and 2x minus 5 is equal to y, they're both equal to y, that means they're both equal to each other. All right? Alternatively, you could kind of look at it and say, if y is equal to x plus 2, what it's telling me is that y can be replaced with x plus 2 in the second equation. So if I make that substitution, I get x plus 2 equals 2x minus 5. Now I went from having two equations with two variables to one equation with one variable. Ultimately, I want to solve for the value of x, so I'm going to use my properties of equality. I'm going to subtract off of 2x. I'm going to use another property of equality. I'm going to subtract off of 2. That's going to give me a negative 1x, or just negative x, is equal to negative 7. Which makes it pretty clear that x is going to be equal to 7, but if not, you just divide both sides by negative 1. So we get x is equal to 7. Now what we're going to do is choose one of the two original equations. All right, just what I said up here. Choose one of the two original equations, whichever one you deem to be simpler to work with. All right, so I'm gonna take the first one. It looks a little easier. So y is equal to x plus 2. So y would be equal to 7 plus 2, which makes y equal to 9. All right, so my solution, always in the form of x comma y, would be 7 comma 9. So this time, I'll put it into Desmos after I did all that work, just to verify it. So y is equal to x plus 2. Y is equal to 2x minus 5. I would tap on the intersection. I get 7, 9. That's what I got algebraically. I need to be prepared to do it both ways. We're in good shape here. All right. So you're on the hook for pages 10 through 12. I might have wrote 10 through 11 in the update. I meant 10 through 12. All right, so yeah, I'll leave this up for a few minutes, but the rest of the time is yours to practice. And you want to solve a system of equations using substitution, it involves exactly what the title suggests. What you're going to do is you're going to substitute or replace part of one equation with part of another equation. All right? So we're going to look for an equivalent relationship that allows us to make that substitution. All right? So looking at number 5, we want to make an observation. The first observation that we could make is that y is equal to x plus 5. All right? So y is equal to x plus 5 tells us that y can be replaced with x plus 5 in the second equation. All right, so if I tell you that these two y values are the same, this y and this y, and that y is the same as x plus 5, it follows that y can be replaced with an x plus 5 because they're the same. It's like if I tell you that x is equal to 2, that means that I can replace every x with a 2. All right? You know, something in a more practical sense, if I tell you, you go to like rent a car, and I tell you that these two cars are equivalent. Like you go to rent a car. I mean, you've probably never done this, but maybe you've been there when your parents have done it. You go to rent a car at the airport, you're going on vacation, and they say you could have any car from this line. And you see they get the Chevy Malibu, they got the Honda this, the Toyota that, whatever. You could take any one of those cars because they're all equivalent in value according to the rental company. All right, so they're replaceable. So you get into one car, you're like, I don't quite like this one. It's not a perfect fit for me. You get out, you get into a different car because in the mind of the rental company, they're all the same. All right, so that's what's happening here. Even though y and x plus 5 look very different, they're the same based off of what the first equation is saying. The first equation is saying y and x plus 5 are the same, which means that they're interchangeable. All right, so in my second equation, I'm going to say, all right, well, I don't want the y there. I want the x plus 5 instead. So then it begs the question of, and it's a legitimate question, why would we want to do that? Like, why would I want the x plus 5 instead of the y? Well, originally we had two equations with two variables. Each equation had two variables in it. All right. The problem with that is that you could never solve for x or solve for y in terms of just numerical values. You wouldn't just get x equals some number, y equals some number. You would get x equals something involving a y. You'd get y equals something involving an x. If we could get rid of the y and replace it with an expression involving x, now I have the means by which I can solve for x. All right. The parentheses don't really need to be there because we're adding in parentheses. So it's really the same as saying 3x plus 5 is equal to negative 11. They would need to be there if there was a minus, so I always throw them in anyway. But you probably learned this in the past. If it's plus parentheses, you just drop the parentheses. The rationale behind that is there's an understood 1 in front of the parentheses. If you distribute that 1, you get no change. It still ends up being a positive x and a positive 5. All right. So either way. Anyway, we still have that understood 1 in front of the x. 3x plus 1x is 4x. 4x plus 5 is equal to negative 11. All right. Now I want to get x alone. These are properties of equality. So I'm going to subtract off a 5. And I'm looking at 4x is equal to negative 16. I want to get x alone. I'm going to use another property of equality, this time division. So I'm going to divide by a 4. And I get x is equal to negative 4. All right. So through this process of substitution, I've now discovered that x is negative 4. That's great. I need y, though. I also need y. All right. So what we can now do is choose one of the two equations, because we don't need them both. Choose one of the two equations. Original equations. Replace x with a -4 and solve. All right. So you choose one of the two original equations, replace x with a -4 and solve. I'll explain in a little bit why I put a box around the x and a -4. All right. So you look at the two equations. Hey, I get to choose one of them. Well, if you're anything like me, or actually if you're anything like, you know, a person who doesn't like to do extra work, you're going to look for the one that's easier to work with. You know? So you look at the two equations and you say, well, the second one looks a little funkier. I'm going to take the first one. It looks a little easier to work with. All right? So y is equal to x plus 5. And this has the added bonus of already being solved for y. Since ultimately that's what I have to do. I got to figure out the y value. I'm in pretty good shape here. All right? I'm going to replace the x in this equation with what I now know x to be, a -4. So y is equal to -4 instead of the x plus 5. -4 plus 5 is equal to 1. And so my solution is always x comma y. It's an ordered pair. Coordinates on a set of coordinate axes on a graph. X comma y, -4 comma 1. All right. There's a nice easy way to verify your answer on Desmos. Y equals x plus 5. Oops, x plus 5. Type it in. 3x plus y equals -11. See where they cross, just like yesterday. It's the same type of question. It's just we're going about it in a different way. When we look to solve, this is the algebraic solution. Yesterday's method was a graphical solution. All right, so the graphical solution was actually physically drawing the graphs of the lines and seeing where they cross. There's no reason why you can't use that to verify your algebraic work. All right, so graphically we got -4, 1. Algebraically we got -4, 1. All right, this actually goes a lot quicker than the way I'm making it seem, because you see all this writing here and you're like, oh, this is going to take forever. It takes a few steps, but these are. Oh, dropped the Apple Pencil, broke the Apple Pencil. Got a little runner there. Oh, yeah. Thank you. That's what happens when you're ham-handed like I am. Alright, so that's kind of in. Alright, moment of truth. Is it still going to work? And this is all getting recorded, which is great. All right, so far so good. I think it's all right. That little O-ring is supposed to go into the other end, but whatever, it'll be all right. All right, we'll see. Okay, I think it's okay. Yeah, but it's not terribly challenging. There's only a little bit of real work here. The rest of it was just a fair amount of notes. All right. So looking at number 6, solve each system of equations algebraically using the substitution method. So same question, but this time they're both equal to x. All right. So it's a little interesting setup here. Same idea though. All right, so in fact, I'm going to just copy paste my notes here, which everybody loves when I do, because it's like, oh, it'd be great if we could do that. You can. You just you know, need the technology to let you do it. All right. So I'm just going to get some of the things out of here because, there we go. That's why he made those boxes. All right. So here we're seeing in my first equation that x is the same thing as y plus 10. X is y plus 10. What that means is that x can be replaced with y plus 10 in the second equation. All right. So in my second equation, I can replace the x with a y plus 10. All right, so I go ahead and do that. So y plus 10 instead of x would be equal to 2y plus 3. All right. So I'm going to solve this equation. I'm actually going to do this next problem with you. So let me get rid of this work here real quick. All right, I'm going to solve for y. Because I've eliminated the x variable, I'm left with just the y variable. So when I solve my equation here, it's only going to have, it only has y's in it, so I'm only going to get something in the form of y equals. All right, so I'm going to subtract off a 2y, subtraction property of equality. I'm going to subtract off a 10, also subtraction property of equality. So negative y is equal to negative 7. Right? If negative y is equal to negative 7, it follows that y would be equal to 7. But you could also divide both sides by negative 1. Division property of equality. All right. So we have that value. So what we do, again, is we choose one of the two original equations, replace the y with a 7, and solve. All right, choose one of the two original equations. Because we solved for y equals and got a result of 7, we would now know that y and 7 are equivalent, so I can replace the y in one of the original equations with a 7. I still like the first one a little bit more. So x is equal to y plus 10. So x is equal to 7 plus 10. So we get a result of 17. Our solution is always going to be in the form of xy. The x value comes first, 17. The y value comes second, 7. Verify on Desmos, putting in our original equations. I don't see an intersection on my screen, so I'll zoom out a little bit. Tap on that intersection, 17.7, we got it. All right. Now, the last one that we'll do together is number 7. That's a little bit on the trickier side because you see in both cases, or in either case, or in neither case, depending on what's grammatically correct, we're not looking at any situation in which an equation is solved for y equals, x equals. God, I hope they're learning this. And we'll find out, I guess, at some point. So we have two equations that we can work with. I don't even know. So we have two equations that we can work with. What we want to do is solve one of them for y in terms of x, or x in terms of y, whichever is more convenient. All right, so you just kind of, that's the thing that kind of throws people for a loop. It's the convenience part. What's more convenient? Well, what's convenient to me and what's convenient to you are two different things. All right? So you like to go to Salsa Fresca. I like to go to Chipotle. Chipotle is more convenient to me. It's only a mile away. Salsa Fresca is only a mile away from you. Chipotle is like 30 miles away from me. I have no idea. You know, bottom line is what's convenient to one is not necessarily convenient to another. You might look at this and say, oh, I like the second equation better. I personally like the first one better, and I'll show you why I think the first one's better. All right. Now, I could say, yeah, I like Chipotle better because it's only a mile away from my house, and you're like, oh, that sounds great. Where's your house? White Plains. Okay, that's no help. So, the rationale is what makes it an important connection. All right. So my reasoning for selecting this one is I think it's going to be easiest to get X alone. All right. Now, why X? Well, I didn't have an opinion over which variable I should try to get alone. I just looked at it and said, okay, I got two variables, X and Y. Out of those two variables, which one is it going to be easier to get alone? I think it's going to be X because all I'd have to do to get X alone here would be to add Y to both sides. And so I'd have X is equal to Y minus 3. We always try to keep the variable in front. All right. Now, I didn't do anything to the second equation. Second equation I'm going to leave as is. 2x plus y equals 12. I'm sort of thinking about these two equations now as a brand new problem, kind of ignoring this original setup. All right, that one step in the beginning just made it a lot more convenient. All right, so I'm going to take my notes from before, and I'm just going to replicate, copy, paste, make it tiny, All right, so a couple of adjustments along the way. This is not going to be here anymore. So I'm looking at my equation here, or my system of equations, and saying, okay, X is the same thing as Y minus 3. So Y minus 3 and X are the same thing as one another, which means that the X in my second equation can be replaced with a Y minus 3. So the X can be replaced with a Y minus 3. So 2, instead of the X, I put a Y minus 3. Now I have to do a little distributive property here. All right, a little distributive property to clean it up. 2 times y is 2y. 2 times negative 3 is negative 6. Plus another y is equal to 12. Combine our like terms. Our like terms are 2y and y. 2y plus 1y is 3y. So put these two together. We get 3y minus 6 equals 12. All right, I'm going to add a 6 to both sides, addition property of equality. So that's 3y is equal to 18. I want to get y alone, so I'm going to divide both sides by 3. Division property of equality, and I get at long last a y equals 6 in this case. So I can replace the y. After I choose one of the original equations, I'm going to replace the y now with a 6 and solve. So we always go back to the original equations. All right, it's kind of like a standard operating procedure. Because if it's going to verify, if you're going to verify your solution, we're going to use the original equations to do that on Desmos. We want to make sure that if there's any discrepancies, the discrepancies come not from plugging it into something that you had already made a mistake with. It might actually check out. All right, we would want to check it in the original equation. So the first one looks slightly easier than the second one. And honestly, I think that might be a psychological thing on the part of the people who make questions. They tend to type the thing. When you're typing a question, you tend to type the easier thing first, then the more complicated thing after that. So historically, I've gathered over the years, and I've seen this very often. I've done it myself. The first equation almost always is the easier one to work with. All right? There are exceptions, of course, but that's almost always the case. All right? So you grab the first equation if you want, or you mix it up, grab the second equation. Replace the y with a 6. x minus 6 is equal to negative 3. We'll have to use a property of equality here to get x alone. So add 6, add 6. We get x is equal to 3. And our solution, again, x comma y, 3 comma 6. We want to make sure it's right. You don't want to do all this work and then find out you're wrong, especially on a test. So you put in your original equations. In this case, 2 of them because it's a system. 2x plus y equals 12. See where they cross? They cross at 3, 6, so we know we did it right. Some of equations. The simpler the equations, the easier it'll be. The more complicated the equations, the more complicated the process will be. All right. But the idea is that we have 2 equations with 2 variables. We want to pare this down to 1 equation with only 1 variable. All right. So what we do is we take a look at one or both of the equations. That's what makes it tricky because you don't always know where you're supposed to start. But I'm going to start with the first equation here. And I'm going to take note of this expression. Okay? What that first equation tells me is that y is equal to 3x plus 1. Which is kind of weird to say because it says it right there. But it really means that y is the same as 3x plus 1. All right. It kind of feels like you're going the reverse of like a word problem. Normally you're given a word problem and you want to convert it over into equation form. Here we're kind of thinking about it in word form because when you actually think about it that way, it's like, okay, so y and 3x plus 1 are interchangeable. All right? That allows the substitution to happen because the consequence of that is that we can replace y in the second equation with the 3x plus 1 because they're the same. They're interchangeable. All right? Quick analogy. Let's say you're talking about football. I don't know how many of you like football, but let's say you have 2 quarterbacks on the roster and they're both roughly equivalent in ability. All right. Most of the time it doesn't work out that way. Usually one's better than the other. That's why the other one's the backup. But let's say the backup is almost as good as the starting quarterback. So the starting quarterback gets injured, the backup goes in, the team performs the same way. Why? Because there was really no difference between the 2 players. All right. So it was a even substitution, an equivalent substitution. Whether the team played with the starter or the backup, it didn't make a difference. All right. So that's a quick example. All right. So what that allows me to do is replace the y in the second equation with the 3x plus 1. So instead of saying y equals 5x minus 3, I'm going to say 3x plus 1 is equal to 5x minus 3. Just by making that substitution, I went from having 2 equations with 2 variables to a single equation with only 1 variable, that variable being x. All right. So now I would solve for x. All right. It's an equation, so use properties of equality to get the job done. So I'll subtract the 3x from both sides. Subtraction property of equality. I'll add a 3 to both sides, addition property of equality. Little cancellations here. We're looking at 4 is equal to 2x. Division property of equality. Divide both sides by 2. And we get the value of x is equal to 2. All right. Now, when you're solving a system of equations, we need not only an x value, but we need a y value. All right. We just figured out the value of x. X is equal to 2. We need the corresponding value of y. So what we're going to do is choose one of the two equations. Really, the original equations. And replace x with 2 and solve. All right. So you do have the ability to choose which of the two equations you want to work with. Generally, you want to go for the simpler looking one. All right. But it ultimately won't matter, because we're looking for where these two equations are consistent with one another, where they're equal to one another. So every aspect of the equation has to be equal, both x and y. So if I choose the first equation or the second equation, it won't make a difference. I'm going to choose the first one. Numbers look a little nicer. So y equals 3x plus 1. I'm going to replace the x with a 2. And then I'm going to solve. All right, 3 times 2 is 6, plus 1 is 7. So that's my y. And so my solution, or my final answer, however you want to label it, is always going to be in the form of x comma y, because it is an ordered pair, or a set of coordinates. X first, then y. The x value is 2, the y value is 7, and so that's our answer. All right, very easy to check. All you have to do is type in your two original equations in Desmos. Oops. I have my two original equations. Just like yesterday, it's just a matter of determining where they cross. And a nice intersection there at 2, 7. That's what we got algebraically. All right. We have to be prepared to answer these types of questions algebraically. That's why we're doing it this way. If a question doesn't tell you to do it algebraically, you could do it any way you want. And in most cases, that means put it into a calculator and see where they intersect. All right. Let's do another one, because they're not all this quote-unquote easy. I'm just going to do a little copy-paste job here. All right, so number 2, we got negative 3x plus y is equal to 1, and then y is equal to negative 4x plus 8. All right, so here we're saying, again, we want to substitute from one equation into the other, but it would make the most sense to say that y is the same as negative 4x plus 8, because we have that nice relationship written right in front of us. All right. So y is the same as negative 4x plus 8. So we can replace the y in this, in this case, it would be the first equation. With a negative 4x plus 8. All right. So what we do generally is we look for the equality. We look for what one variable is equal to in terms of the other variable. All right. So in short, we're looking for x equals something or y equals something. All right. That allows us to make the substitution, because I know that y is negative 4x plus 8. That allows me to replace any y, because that's our equivalent relationship. It allows me to replace any y that I see. I could have 10 equations here. I could replace every one of those y's with negative 4x plus 8. All right. So if I take my first equation here, negative 3x plus y is equal to 1, instead of the y, I'm going to put in the negative 4x plus 8. All right? So really, when you think about it, it's really the same as saying negative 3x plus y equals 8, but I'm saying that the y is really negative 4x plus 8. All right, just making that quick substitution. Combine our like terms. You get negative 7x plus 8 equals 1. And the reason we can combine like terms is because there are like terms to combine now. All right? We were able to take a y variable and replace it with an x variable. We went from two equations with two variables down to one equation with one variable. So properties of equality apply. I can subtract the 8 from both sides. So I'm looking at negative 7x is equal to negative 7. I want to get x alone. Division property of equality, divide both sides by negative 7. And I get x is equal to a positive 1. All right. So then, just like the previous problem, I choose one of the two original equations and replace x with, well, now we know x is equal to a positive 1. So I'm going to replace x with a 1 and solve. Again, it does not matter which of the two equations you choose. I'm going to choose the second one, y equals negative 4x plus 8, not because I chose the first one in the previous problem, but because it's already got y alone. And I'm looking for y. All right, so if I choose the equation that has y all by itself, then it's going to be an easier computation because all I'd have to do is plop in a 1 here for x, and we get a result of 4. We have x is equal to 1, y is equal to 4, so we have our solution, 1, 4. X comma y. Always the x first, followed by the y. You can always check your answer, check your work. All right? It's just a simple matter of typing in your original system. It's to the point where you start questioning the need to do all this stuff to begin with. But the algebra skills are necessary for the later years. So when you get to algebra 2 and pre-calc and calculus and stuff like that. All right? So we want to make sure we have good algebra skills for those classes. But for now, I admittedly look at this and say, if I were a student, I'd be like, well, why do we have to do it using this like long way when we could just type it in and just do this? I'm with you. It's a requirement. For now, you just got to believe that it'll be important, but down the line, you'll see why it's important. And it's kind of unfortunate in that regard. I never like using that as an explanation, but that's what it is. All right, we're actually going to flip back a page and do, I saved this problem for last. It's number 8 on page 11. I'm piecing together all the videos from throughout the day, and I'll post it all up later, so if you want more explanations, you can grab it from the videos. All right, but this is an instance, if you look at number 8, it's an instance where neither of the equations are solved for y in terms of x or x in terms of y. You see, I mean, it's zoomed out big time, but in the case of number 1, we had y alone at least once, in this case twice. Here we had y alone. But in this one, we have nothing alone. We don't have a y alone, we don't have an x alone. So our first step for a problem like this is going to be to get y alone or get x alone. All right, it doesn't matter which one you get alone, as long as one of them is alone very early in the process. So let's say I take my first equation, y minus x is equal to 8. I want to get the y alone. I'm going to add x to both sides. So I'd be looking at y is equal to x plus 8. All right, you could say 8 plus x or x plus 8. We typically want to write the variable first. Addition is commutative. You can go in either order. So it doesn't matter which one comes first, but typically we want to have the variable part first. All right, I'm going to rewrite the 5x plus 2y is equal to 9. And now I'm essentially going to think of this as a brand new problem. I'm going to think of this as the question that was being asked. All right. So with that in mind, I can kind of do a lot of the same stuff we were doing before. Because here I can see that y is the same as x plus 8. So that means that we can replace the y in the second equation with x plus 8. So I got, it's kind of a mess in the second equation, but I do have a y in there. That y can now be swapped out for an x plus 8. So what I would do is rewrite that second equation, 5x plus 2, instead of the y, I would write x plus 8. It's a linear equation. One equation, one variable. Not as nice as the other problems, but it's still manageable. All right, we just got to use an additional property, a couple of additional properties. All right. First, I'm going to have to distribute. I'm going to have to run through the 2. So 5x plus 2x plus 16 is equal to 9. Then I'll have to combine like terms. You got 5x plus 2x is going to give you a 7x. Then I'll use a little subtraction property of equality. Subtract off that 16. And then I'll use the division property of equality. Divide out that 7. And you get x is equal to negative 1. All right. So I have an x value. I want to choose one of the two original equations and replace the x. This x turned out was equal to a negative 1, which means every one of these x's is equivalent to a negative 1. Anywhere I see an x, I can replace it with a negative 1. It's just a question of which equation I want to work with. You want to work with the simpler of the equations, which looks like the first one, y minus x is equal to 8. You always want to go back to the original. Y minus x is equal to 8. Replace that x with a negative 1. The only thing you got to be careful about here is we got a double negative. There's a negative built into the equation, and we're substituting in a negative. All right, two negatives make a positive, so y plus 1 is equal to 8. We got to use a little subtraction property of equality. Subtract off the 1, and you get y is equal to 7. So a couple extra steps, but the same principles are at work here. All right, you're still solving it by eliminating a variable through substitution, and then once you do that, you identify by solving using properties of equality the solution to either x or y, and then substitute that into one of the two equations to get you the other variable. So my solution here would be negative 1, 7. And again, very easy to verify in Desmos. Just take your two original equations in their original form. Y minus x is equal to 8. 5x plus 2y is equal to 9. See where they cross? Negative 1, 7. All right. Very important to remember for multiple choice questions on a test or quiz. You don't have to show any work. So what I'm showing you on Desmos could be how you come up with the answer. You do have to be prepared for a free response question, you know, a show all work type of question to do all this stuff. But for the multiple choice, type the two equations in, tap on the intersection, and call it a day. All right, so you want to make sure that you're using the resources that you have available to you. All right, I'll get you with the algebra. You'll have to do that at some point, but don't go forcing that to happen when it doesn't need to happen. Because I know there's some folks that are resistant to Desmos and calculators and things like that. But this is an instance where it's going to do the work for you, so why wouldn't you use it? All right, so just keep that in mind. All right, so with the remainder of class,